Hi, and welcome to Quick Add Maths on integration. Integration uses the symbol that looks like a squiggle. Integration is the inverse of differentiation. As an example, the integral of x to the power of n is equal to the product of 1 over n plus 1 and x to the power of n plus 1 plus c. As with differentiation, the integral of the product of a scalar with a function is equal to the product of the scalar and the integral of the function on its own. Also, the integral for the sum of two functions is equal to the integral of each function being totaled together. The expanded form of indefinite integrals worth remembering is that the integral of ax plus b to the power of n is equal to the product of 1 over the product of a and n plus 1 together with ax plus b to the power of n plus 1 plus c. Tutorial question 1. Find the given integral. It should come to the product of 12 and x plus 1 to the power of half plus c. Tutorial question 2. A curve is such that its dy dx is equal to 4x plus 1 to the power of 4. Given that the curve passes through the point 0 and minus 1.95, find the equation of the curve. By first solving the integral with a plus c, you could use the point as the x and y values to solve for its c, hence obtaining the required equation. This page contains more integrals, that is an inverse, for its differentiated exponential, log, sine, and cos. Tutorial question 3. Find the given integral. This would be 5e to the power of x minus a third e to the power of 3x plus c. Tutorial question 4. A curve is such that its dy dx is 5 over 2x minus 1 for x larger than 0.5. Given that the curve passes through the point 1 and 3, find the equation of the curve. Again, you would solve for the integral with the plus c, and at the points 1 and 3, this is both the x and y values that would help us solve for c to get to the required equation. Tutorial question 5. A curve is such that its dy dx is cos x minus sin x. Given that the curve passes through the point pi over 2 and 3, find the equation of the curve. Here again, you perform the integral of an expression with a solution that is with a plus c. Then insert the given values for its x and y to solve for c to get to the required equation. Tutorial question 6. Show what is given and then find the integral of the given expression. You would apply quotient rule to solve for the differentiation of the given expression. From there, you could apply what is obtained from the differentiation to help solve for the given integral. Next, I wish to introduce definite integration, which is an integration of a function within two defined limits, and can be written as shown. As an example, the integral of x squared within the limits of 1 and 4 can be solved as being 21. As with differentiation of a function representing its gradient, the integration of a function represents its area under the curve. As an example, the integral of x squared within the limits of 1 and 4 is the area of the shaded region as shown for the graph on the right. And as it gets more complex when you're asked to find the area bounded by two curves, this can be made simpler by subtracting the area from the curve sitting further away from the x-axis against the curve sitting nearer to the x-axis. Tutorial question 7. Find the quotient and the remainder when 4x squared plus 4x is divided by 2x plus 1. Hence show that the integral of the given expression is equal to 2 minus a half log 3. The first portion can be solved by pure division, and we would use this as part of solving for its integral to get to the solution of 2 minus a half log 3. Tutorial question 8. Find the area of the shaded region. This would be the integral of the given equation within the limits of pi over 4 to pi over 2, which would solve for it being pi over 4 plus a half. That's all for Quick Add Maths on integration. If you found this beneficial, do subscribe to further seek out our other videos under the KT Tutorial channel.